Okay, I'll get started, I think. So this is a talk on one of those new web tools I teased a little bit in my last my first talk. So this is Telemetry dashboard. So it's a read-only, user customizable dashboard as a web tool. I want to make it very clear, it is not a GCS. It's read-only, you can't send commands, it won't plan missions, won't do anything. It's just for displaying information that comes in over the telemetry. So it just connects with binary mavlink over WebSockets. You can do WebSockets via PyMavlink, but in this example, we're going to use Mission Planner. It's just a JSON definition that allows you to load and save the dashboard that you've set up, and you can send it to your friends and share it around like that. User-defined widgets, so we'll have a look at some widget examples, and it does currently need an internet connection. So a few of the web tools will run completely offline. This one won't. It still has to go and load its packages from CDNs and things. But potentially we could make it run completely offline in the future. And you can find it fomo.archipelot.org tools, web tools, telemetry dashboard. It is live at the moment, so all of you with laptops can go and have a look and play about as we go through the talk. And that is that is my slides done. So the rest will be a really long demo. First of all, I'm just going to run Tittle, just so we've got something that we can connect to. I'm then going to go ahead and connect up with Mission Planner. So that's Mission Planner connected, so fairly normal setup so far. Then we're going to go over to Web Tools, so fomo.archipelot Web Tools, work in progress, and then down the bottom here, Telemetry dashboard. And you'll see straight away it's connected up to Mission Planner. So when you first load it, it knows what port Mission Planner is sending on, so it goes and has a look for Mission Planner. So it's just connected straight up. You can see the vehicle here, and a few sort of example widgets and things. So basically this is sort of a default view as a sort of little teaser of some of the things you can do. You can see we've got some messages, a few values, a little HUD thing, ground speed, airspeed, the map. So let's just, we'll change to takeoff mode. Just so there's something going on. So you can see we're flying around there, and we can zoom in and out on the map and things. We're using Leaflet again here. Everyone uses Leaflet. So that's sort of this sort of landing page and dashboard. If you're not using Mission Planner, you can, the little connect, this link icon, you can disconnect and reconnect. So if you were using, if you go on the little question mark here, there's a link to like an example of how you can forward WebSockets if you're using PyMavlink. So if you're not using Mission Planner, if you use latest PyMavlink, you can forward from that as well. I'm sure when we twist Trojan Pitter's arms to do a new Mav proxy release, you'll be able to just do tag out WebSockets as well. So that's how you can connect, and that's the default dashboard. But the key thing is sort of the user configuration. So I can come down here and I can enable widget edit, the little tick box there. And I can't interact with the widgets anymore, but what I can do is change their size and move them around and pop things out of this little subgrid and things like that. So that's sort of the key, or the key edit functionality. You can set this up, however you want. You want a massive number just reading out voltage and nothing else, you can totally do that. And then you can double click on the widgets and it'll bring up this little menu, which is specific to each widget. It lets you, you can change the label here and that will update. You can, you can plot to 20 decimal places if you like. a few options. You can change the color, things like that. So that's, oh, and it has a big long list of all possible Mavlink messages. If you're looking for some data from a particular message that you want to display, it is in here. So we could change to attitude. It'll error out because altitude is not a valid field in the attitude message, but we could change it to pitch, for example. And there's a scale factor. So in this case, my scale is probably wrong because I don't think we've got, whoops. Yeah, that's a bit more sensible. So because this just is raw Mavlink, you might have to go and double check in the Mavlink definitions what unit exactly it's being, the value has been sent in, and then you can use the scale factor to get the unit that you would like. So if you would like this in feet, for example, you might want to, times by 0.3 or whatever. Go and look up your own conversion factors. So that's that widget. There's a graph widget. Again, you can double click and change the labels and scales and how the duration of the plot. So you could change it to 10 seconds and it all goes past much faster. For example, the subgrid widget, we could have 5 rows, for example. You can rearrange everything and put things to make it a bit smaller, but you can put things into the subgrids and things like that. I've got messages here. You can change all the colors for the different severity levels of the Mavlink messages, for example. I think that's about it for these examples, but sort of or that level of configuration is a little bit of a trick. That's just the top level. So actually all these widgets use the same underlying widget. And if we double click, you'll see there's a little edit here. So we can click on that edit, and that actually brings up the code for that widget. So now I can change it, and I could add a second line, or change the color, or make it flash, or you can do whatever you like. This is JavaScript in this example, and it uses Plotly. So one of the reasons that we can't load it doesn't work offline is that we need just these Plotly to load in the package. So there is a lot of things you can do. This graph is quite a nice example. So if you wanted, it has the set interval thing. So you can, it's an example of doing callbacks within a widget. So you can update things. So if we were to disconnect the vehicle, for example, you will notice that the plot still keeps moving. So that's because it's got that callback. So the data stops, but the plot keeps updating. So that is an example of that. We'll choose one of the sort of simpler ones and have a little look at the actual code. So let's go and have a look at the code for just this basic value. So if you're familiar with JavaScript and HTML, this is fairly straightforward. We add a little label element. We append that to the widget. We center it, make a little div that we put the actual value in. In this case, the number is actually an SVG, which is what allows it to scale nicely rather than having a fixed font size. By using SVG, it nicely scales. There's a resize callback that makes it do that scaling. And then there are sort of 2 methods that you have to provide in your script. So it's quite similar to Lua scripting, where you have to do the return update. There's a handle message method that you must define, and this checks the message ID. And the options.message is the options from this field here that you fill in the form. So we check if it's the message we want. If we haven't got the field that we want in the message, we throw an error. Otherwise, we get the value, we apply that scale factor. So that's this scale factor that we were playing around with earlier. And then we just set the HTML for that value after applying that round to decimal places. And there's also this handle options. So the handle options is what's called when I change one of these options here. So for example, the color. If I change the color, it'll call this handle options. and then it updates the fill of that particular value. And of course, because it is just JavaScript, we can easily edit it. So if I find, for example, the battery message, battery status, no field pitch in the battery status message. Perhaps we want, where's it gone? Current. Probably want to divide by 100 on that. That seems like a reasonable current. Of course, it's current now. Current in amps. And we'll change the color back to black. Then what we might want to do, for example, if you know your vehicle is going to struggle if you go above 10 amps, we could do if value greater than 10, copy and paste, because that's how everyone codes. Wonder if words work. Yes, they do. So then we get a lovely red color. And then if I go and disarm the vehicle, hopefully that will. It's still red, and that's because we need to do an else to turn it back. So we'll copy this option here so that it goes back to the color that is set up in the menu. And if I arm again, hopefully before we crash, we just about got there. So now it's gone red again because it's gone up. So, you're right. Got some backseat coding going on over here. So that's sort of some example of one thing you can do. Obviously, you can go as crazy as you like. So you could run FFTs whilst your vehicle's flying along and plot things like that. So that's one of the simpler examples. I'll just reload the page and we'll have a look at some other examples that I've done. So you'll notice that it's prompted me here. The changes you've made may not have been saved, and that's because I've messed around with my dashboard here. I've edited a few things, and I haven't downloaded the definition of that of the dashboard. So it warns you, oh, if you do reload, you're going to lose all this. So I'm going to cancel, and it opens this little box for me, and I'm going to hit save, and that's just a big, enormous JSON file with the definition and the layout of all the widgets. It's got all those. Like the options in the form set up there. So then I could send that to someone else, and you could load that up in the web page, and you get exactly the same view as me. Yep, it's all in the JSON. Yeah, so it is exactly. I could also, whoops. Oh no, it's okay. It's recovered. I could also, if I double click, you'll see there's a download thing here. So I could just download that individual widget and I could send that. So if I've spent ages and got a really nice map widget, for example, I could share that with someone else. And then we could load that in. So it will, that will have saved into my download. So I've loaded in another copy of that widget. You can also, if you double click, there's this little copy button. So it'll just, again, copy. So if you've got a nice widget set up, you can copy it and maybe you change the options here. If you double click, there's also delete, which is hiding under the zoom thingy. So you can double click and delete widgets, just like that. So I will just reload and we'll go back to the original view. So the other thing, I'll have to re-enable edit here. The other thing I forgot to show is there is another tab in this edit menu. So there's the form edit. So this is the little pop-up that you display to the user saying, how many decimal places would you like? So that's just an option in this form, and you can drag in new items into this form. It uses a library called form.io. So I could say extra label, for example. And then it gives you an API name. So that extra label is how I'd access it in the code then. So I can save that, and you'll see that has appeared when I close this so it reloads. That should appear at the bottom here. And then if I wanted to access that within my code, it's one of these options. So it will be options.extra label in this case. So you can provide sort of simple options that you might want to let a user configure. And if you want to do advanced stuff, you can just come into the code if you want to do some really clever stuff. These are all sort of quite basic examples. I was hoping everyone would go and have a play about, and you can come up with some really complicated widgets that we can add. So that's the editor. We'll delete this map. So if you click on a sort of empty bit of the screen, it will crash. There we go. It's got a sort of little palette of available widgets. So for example, there's a Maverick inspector we could drag on to our main thing, and that just gives us I can't interact with the widget because I'm still in the edit view, but if I disable edit, then I can scroll down and expand things. So actually this is super useful when you're writing widgets, because you might not know exactly what the different fields are called in Maverick messages or what exact Maverick messages are being sent. So this is sort of handy for developing widgets. So you can come and see what all the fields are. Re-enable edit. So we've had a look at messages is down there. There's this example. So this is a HTML example. So if we edit this, rather than being JavaScript that we edit now, it's actually just HTML. So it's just included by an iframe. So if you want to do something even more advanced than just JavaScript, you can actually type it directly in HTML as its own little page. So that is sort of more powerful again. The other thing that I should just do an example of, we'll use one of the JavaScript widgets, is if you do have an issue, if I just type in random stuff, it does give you a little tip. So it gives you the error and the line number in this code. So it's should be reasonably familiar if you're used to coding. You can go and find where your error is and debug that way. So I've done a few examples. We'll just make a little bit of space to show the sort of thing that you can do. So it's warning me I've edited this widget and I'm trying to delete it. So I should download it if I want to keep it, but I don't want to keep it. So I can load in a widget and we'll go to our example. So there's an image example. So we get to load an image. So this one is useful because the image is embedded in the form here. So it doesn't go and like fetch the image from the web page. It's actually embedded in the form. So if you've got like a custom logo, or you want to like show like a top-down view of the vehicle, for example, is something I've been thinking about doing, and you can sort of label motors and things like that. So this is a way that you can embed the image, and this uses the raw HTML. It just has a div with an image in, and then we basically set the source of that image to the URL that the form gives us. So that's a slightly tricky thing to work out with the form, to allow embedding the image in the actual JSON file that you download, and then you can send to people. So that's an example of that. We'll delete that one again. So I know there's a Ross talk next. So I learned about URDF files, which is what Gazebo uses. So you could also load a sort of 3D, whoops. And we'll turn off edit so we can interact with it. So a 3D view of the aircraft. So it's, because URDF is pretty standard with ROS, you could quite easily get a 3D model of your exact aircraft in, and you'll notice that the propeller is spinning. If I just, we'll just disarm, and we'll switch to manual. Will crash. Where's my settle instance gone? So if I do controls and zoom out, so the elevator is actually in the shot, you'll notice that actually this mirrors the control surface movements of the actual vehicle. So this would be super nice. For example, if you're selling a plane, you could set up a little widget that would do like a pre-flight for you. It could actually walk you through, if you put your stick to the left, the 3D model of the plane, it should do this or that, and you can check all your control surfaces are moving. The other thing you could do is you get feedback on position from servos and things like that. So you could actually mirror the actual state of the vehicle here in a 3D model. So we'll just have a quick look at that. So on the form, it's just embedding all the files that that sort of define the aircraft model. So it's the same as that image example. It's a way that you can embed these files into the JSON download that you can send to people. Of course, if you embed lots of enormous files, your JSON file also gets enormous. But that's the example of that. Then this is actually a HTML, so it imports 3JS, which is what we use to do all the doing. A little bit. You can see this is where we actually set the joint value. So it reads in the PWM, calculates a normalized value, and then sets the joints in the model using that URDF viewer. So that's an example of that. And then finally, you saw the original map. So you could also write a little widget that displays the vehicle on a weather map. I'm disarmed, of course. I'll just take off again so we can see the vehicle moving. Again this is windy. When we zoom out, you'll notice the weather view comes in. You could also, because this is the wind one, you can also set a pick like weather at altitude. So this could be really useful. You could have it automatically select the correct altitude that you're flying at and show you the weather at that particular location. Unfortunately, the weather view, windy doesn't like it when you zoom in enough. That is the example of how to do that. Again, it's I read the windy how to use the API for dummies and got this working in about half an hour. So it's just some few message requests and things like that. And again, using leaflet. So this is all embedded in that JSON. And in this case, there's only a sort of trail length and auto pan options. So the options in this particular case are really simple. So that's a sort of overview of what you can do. And I think that, or I hope the real benefit of this will be that you can make custom dashboards for your particular vehicle. Like we've been working on a vehicle that has, 3 batteries, 3 ESCs, they've all got temperature limits, voltages, all these things. So we can set up a little dashboard that displays that information efficiently, and we can automate some of the sort of checking process. So even just making the numbers red when they're out of range takes a big load off the GCS operator. They don't have to be scanning numbers and remembering what all the thresholds are in their head. You can quickly set this up to take that load off, warn you, if I see red numbers, we need to take some action, otherwise it's all good. And like the sort of little attitude widget is probably not the actual sort of thing that you would use this for. It's for use in combination with a normal GCS. But it was a nice sexy example to do. So hopefully that gives you a bit of an overview. I'm hoping lots of people are going to have a play with this, design their own widgets, and then you can make a PR and we'll add them to the little widget palette here. And then next steps for this, I hope we can actually save the JSON configuration that is this that you would download. We actually save that onto the SD card of the vehicle. And then when you first connect, it'll go and look, oh, is there a definition for a dashboard for this vehicle? It will load that via MavFTP off the vehicle and then display it. So anyone who can connect to your vehicle can go to this web page, hit connect, and it'll jump up with all the correct information. And then, I don't know, if people are interested, we could potentially, this is read-only at the moment, we could potentially think about, adding some buttons to send commands, things like that. But it is quite nice being read-only because it means no amount of coding mess-ups can crash the vehicle. But potentially we could do, custom actions and things like that if people are interested. Thank you. Any questions?
If we made it not just read only, read write, do you think we could perhaps put like a little chat module in there so you could make it connect to ChatGPT or something and then maybe send messages to the vehicle?
Yeah, absolutely. I mean, that's one of the really nice benefits of being web-based is you get all the web APIs. It's super easy, and there'll be loads of examples.
How, if you give the link to a friend that's watching, how are they getting, if it's over the internet, is Mission Planner uploading the telemetry data to the internet and then to them, or how does that kind of traffic pattern work?
So in the Mission Planner stream in this case is just local. It's just a local stream. So because Mission Planner is running here locally, I can connect that. So you would have to forward them the telemetry, be it either the sort of raw mav link, or you could forward them the WebSocket that they could connect to. So it's only the actual sort of framework of the dashboard that is the online bit. Sorry. What was that? Well, you should be able to edit without being connected. Should work, I promise. Unless I've broken it. Let me. I mean, that's possible. This has only been tested in Chrome. Yeah, so you should be able to edit if you're not connected. I will come and have a look at what's going on. The other thing I forgot to mention, maybe it's obvious. Slower, but it completely it will load on your phone. It's slightly more complicated to forward the mav link to your phone, of course, but I haven't tried it, but I think this would be quite powerful on little tablets and things like that.
For if you're like making this to send to a customer to take a look at it, would there be an easy way to, lock these widgets so that they don't accidentally change them, or, just kind of lock them in place so that they don't?
Yeah, so totally, we'd have to edit the sort of make a locked version. But for example, you could totally host this on your own like server on your own site. When it first loads, there's just a default layout.json. So if you configure all your widgets, download it as a JSON, replace this file. When it first loads, it'll just boot up in your configuration, and we'd have to go and delete the bits, delete the edit button basically. But it would be quite straightforward to do that.
Great. No, that sounds good. Thank you.
Thank you.